exact equation. So the equation is exact if my equal to nx. So this is m and this is n, and it is exact if derivative of m with respect to y equal to derivative of n with respect to x, or we write in the subscript notation m sub y equal to n sub x. The reason of this is if there is a potential function, if there's a function f of x, y, such that derivative of it with respect to x is equal to m, and derivative of it with respect to y is equal to n, and then when we take derivative with respect to y, we will have f of xy, and when we take derivative of n with respect to x, we have f of yx. Since the mixed partial derivatives are equal, we have my equal to nx. And so that's why we check the equation to see if it is exact or not. So we just pretty much do that. The derivative of m with respect to y. Now this is the function with respect to y. So for x cubed here, it's just a constant. So we're going to have for x cubed, that constant. Derivative of y, we just 1. 4 is a constant. Derivative, of course, is 0. So this is just for x cubed. And then ny, I'm sorry, derivative of n with respect to x. Derivative of x to the 4th, that term is for x cubed. Now we do have derivative of m with respect to y equal to derivative of n with respect to x. So the equation is exact. So that's check. I will erase this to make room to solve that equation. Now if it is exact, there exists a function, we call this a potential function, f of xy, such that derivative of f with respect to x equal to m, and derivative of y of f with respect to y equal to n. Right? We work one by one. First, we will consider this f of x equal to y. I mean f of x equal to m. Sorry. So we start with f sub x equal to m, and m is equal to for x cubed y plus 4. So I will write that out for x cubed y plus 4. Now, to solve the exact equation, we will do 2 steps. The first step is integrate with respect to one of the 2 variables. So I will integrate with respect to x to get back the function f. So first, integrate with respect to x. Do that, we get back to the function of x and y. Now integrate for x cubed y plus 4 dx. Integrate with respect to x. Now with respect to x, this is a constant, and of course the 4 is obviously a constant. So we integrate, and for x cubed, integral will be just x to the 4th. The y there is a constant, so we just multiply by that constant. Integral 4 will be for x. Sorry, integral 4 will be, yes, it is for x. and plus a constant. But notice that this constant is independent of x. So instead of plus a constant c, we will write a constant as a function of y, because with respect to x, y, any function of y would be a constant. So the first step is integrate with respect to x, integrate m with respect to x. The second step is we will differentiate with respect to y. That is the second step. Notice that we will not look at this one yet. We just take the derivative of what we just have, meaning this function. We take the derivative of that function. So since this is the function f of xy, when we take the derivative, we will have derivative with respect to y. Now with respect to y, x to the fourth is a constant. X to the fourth is a constant. So I will write that constant. Derivative of y is 1, so we just have times 1, plus derivative of 4x with respect to y. 4x is a constant, so with respect to y, so that will be just 0. And then derivative of g of y with respect to y, we will write g prime of y. Right. So we haven't touched f of y equal to n yet. Now we do that. We'll make this equal to n, and n is equal to x to the fourth minus 1. What we see here is x to the fourth on both sides can cancel out, and we just have g prime is equal to -1. If we integrate, we have g of y, a function of y, will be just -y. Can also plus a constant. I just say we have a constant. Right. Actually, let's not skip that step. So that's what we have. Now we have g of y is equal to -y plus c. We can substitute that into g of y, and we have the solution. So we have the solution in this form, which we start from here. Will be x to the fourth times y plus 4x minus y plus c. Now the solution is we have a potential function that equal to something, to another constant, and if we minus the c in blue, in green on that side, we have another constant on the other side. So in that case, we write the solution as follows. Therefore, the solution in implicit form, we can just say x to the fourth y plus 4x minus y equal to a constant c. As mentioned before, that equal to a c, and then move the green c to the other side, we have another constant. So we write the solution in this implicit form. And to recap, to check if the function, if the equation is exact, we check this condition. And to solve it, there will be two steps. Integrate with respect to x, get back to the function, and then differentiate that function with respect to y, and then we make that equal to n, and then we solve for it.